Oh, hello there. How are you? I hope you're doing well. By the way, do you have any difficulty to process your LiDAR data? Or are you looking for a software that can process your GIS and LiDAR data faster than ever? Don't worry, we've got a solution for you. Have a look.
Hello everyone, what you are looking right now is a global mapper, the best software for GIS and LiDAR data processing. Global Mapper is more than just a utility. It offers a surprisingly extensive collection of analysis and data processing tools in a truly affordable package. Global Mapper is a must-have software for anyone who works with maps or spatial data.
So, before we get to know about Global Mapper, let's talk about who we are. Are you guys ready to join the webinar with us? Alright, without further ado, let's get started.
Good morning, everyone. Thank you for joining with us and welcome to our Global Mapper webinar series. Let me introduce myself first. My name is Lukman Hakim. I am a remote sensing specialist from Geonet Infomedia and I am your host here. You've probably heard about Global Mapper before, the best low cost and easy to use for GIS and LiDAR software. But speaking of LiDAR, today we're going to be covering you a LiDAR module and we're also going to be showcasing the highlights, introducing some of the features and its function. And if you're still wondering what is LiDAR module is, what key functionality does the LiDAR module offer, and how to get the LiDAR module itself, do not worry, because we have a very special guest coming from Blue Marble Geo to answer those important questions. And for your information, Blue Marble Geo is a developer and provider of Global Mapper, so I am very pleased to welcome you, sir, to present your material. The stage is yours.
Hello, everyone. Thanks for joining us today for the latest in our GeoTalks Express series. My name is David McKittrick. I am Outreach and Training Manager here at Blue Marble Geographics. This is the second of our series. Those of you who were with us 2 weeks ago, we started with a very high-level introduction to Global Mapper, not going into too much depth in terms of the functionality, but introducing new users or prospective users to some of the key features and functions. Today, we're going to go a little deeper, and specifically, we're going to look at a component of Global Mapper. As you can see on the screen, we're going to attempt to answer the question, why do you need the LiDAR module? Obviously, a lot of people are using LiDAR, different types of point clouds, so hopefully we can give you enough reason today after introducing the key components of the module for you to take a look at that today. So our agenda today, what are we going to be doing? This is very simple. We're going to answer the question first, what is the LiDAR module? I'm going to do that right now before we continue, what is the LiDAR module? I know there's probably some of you out there that are not familiar with this. Maybe you're new to Global Mapper and maybe never used Global Mapper. The LiDAR module is an add-on. It's something you can add to Global Mapper to allow you to do a lot of processing and analysis of point cloud data. I'm going to stop there because, as you'll see, as we go through our session today, we'll elaborate and expand on that definition. But for those of you who are wondering what this is all about, that is what it is. It's a component of Global Mapper. That is what the LiDAR module is. We're going to begin our session today, and I mentioned I've got some special guests. We're going to begin by introducing some members of the Blue Marble sales team. They're going to give you their view of the LiDAR module from their perspective. We're going to have a little bit of a panel discussion to start with. So you're going to meet some of the team members, but also we'll hear from them as well. I'm going to then summarize some of the responses to the question and come up with a top 10 list. Top 10 reasons why you need the module. And concurrently, I'm also going to be switching over to the application itself and showing you it in action. So we'll go through the list and we'll switch to the application. We'll look at some workflows. I should tell you this is not a technical presentation. We're not going to go into too much depth. This is mostly just an introduction so you can see what that functionality is all about. So let's, before we go any further, introduce the team. We have 4 collaborators on the line. Hopefully they're on the line. Chris Berglund, our Vice President of Sales. Jody Parker, Sales Account Manager. Laura Ramage, Senior Account Manager. And Miles Labonte, our Channel Account Manager. I'm going to let them introduce themselves to you. Are you with us, Chris?
Yes, I am, David. Thank you. So my name is Chris, and I've been with Blue Marble for a little over 20 years. I manage a sales team here, and you're right about lack of travel, especially during our busy season. We all really got used to traveling around and exhibiting and speaking at conferences. So I'm really happy to join, this specific GeoTalks Express discussion that focuses on LiDAR module. So yeah, thanks for inviting me.
Sure. And Jody, are you with us?
I am. Thanks, David. Hello, everyone. My name is Jody Parker. I'm a sales account manager for Blue Marble Geographics, and I support the Eastern US, Europe, as well as Australia and New Zealand. So welcome, and thank you for having me.
And Laura, are you joining us today? Are you with us today?
Yes, David, I'm here. Thank you for including us. My name is Laura Ramage. I've been with Blue Marble for just under 2 years, but in the remote sensing industry for many, many years. I'm responsible for Western US, Canada, and the Middle East.
Excellent. And finally, Miles, are you with us today?
Yes, I am. Hi, David. Thank you for having me. Hello, everyone. My name is Miles Labonte. I've been with Blue Marble Geographics now for about 6 years, and I am the channel account manager. So I primarily oversee our resellers and partners, but I also support users in Africa, Asia, and South America.
It's always very gratifying when technology cooperates. We're a little nervous that some people may not be available. It looks like we're all connected. This is great. Just to kind of put this in perspective, these folks that are talking right now, if this was a normal situation, would quite likely be on the road somewhere. Probably at a conference, trade show, maybe visiting some of our customers, delivering software demos, presentations. So it's a little frustrating for all of us that we're obviously homebound, but we're trying to make the best of it. So I think it's good to have these guys involved in our webinars. This is kind of a slightly different approach for us. And you will be able to obviously get some information about who our salespeople are. You can see their email addresses up there as well. If you want to scribble those down, if you have any questions, feel free to shoot them some emails based on maybe some of the responses they give to the questions that we're going to be asking them or to the discussion that ensues. So why do you need the LiDAR module? In summary, I'm going to come up with 10 bullet points here, 10 answers, and I'm going to transition between my PowerPoint here and the application and give you a quick overview of the functions that we're talking about. Now, as we've mentioned a few times, number one reason I believe that you should take a look at the LiDAR module is because you have a drone. And I know the drone users are out there. I know you're sitting in the audience. A lot of people are using drones. If you have a drone, you'll really want to take a look at the LiDAR module. And let me show you why. Those of you who have attended some of our sessions before will be familiar with this workflow. With apologies, those who are not, let me explain what we're looking at here. This is just some aerial imagery. You can see a top-down view just to give us a geographic perspective. I'm going to turn on a collection of images. These are just picture points that I dropped into the application. These are drone images. Those of you who have not seen this tool, this is what we're going to show is our pixels to points tool. I'm actually going to show you a before and after. We're not going to take the time to go through it, but just to show you the raw material that would be used for this data, I'm just going to use my info tool. I'm going to select one of these little camera icons. Oops, off screen inevitably. Let me drag it into view. This is a photograph. It's just a top-down photograph, of which there are, I believe, 192 dispersed throughout this area. The Pixels to Points tool is an image analysis tool that, based on the overlap between these images, will create a three-dimensional representation of this target area. And it does so in a number of different formats, as you will see in just a second. Let me quickly point to where in my toolbar that component resides. Right here where my cursor is located, you'll see a little button, and if you hover, it even says Pixels to Points tool. This is the tool into which I'm going to load those images. I'm not, as I said, going to go through the process, but I'll just show you. I'll go through the motions here. So we're going to add our loaded picture points. You'll see a little preview. We could add ground control. We can apply certain settings, and we can determine what output files that we want from this process, including a point cloud, an ortho image, and or a mesh. And I'm going to show you all of those in just a second. So obviously there's a little bit more technical information. I should say in one of our future Geotalks Express programs, we're going to go into this tool in much more depth and show you the workflow and show you the settings and show you everything else. So if you're impatient about seeing the details, you're going to have to wait a little bit longer, but we will show you this in more depth. It's a very, very powerful tool. For today, I'm going to show you the end result. Let me turn off the images. I'll actually turn off the base image as well. And I will expand this little list of output files. Let me start with the ortho image. This is a top-down, two-dimensional representation of our target area as it was captured by those overlapping images. Now, this is not a stitched together view. That's what a lot of people assume, that you just kind of mosaic them and kind of stitch them together. No, this is actually generated by analyzing the point cloud. And we're a little bit out of context. We haven't seen the point cloud yet, but this is a gridded raster version of what we generate for the 3D point cloud. But it's 2D. It's a top-down 2D view. It's an ortho image. It's an image where every pixel theoretically is correct in 2D geographic space. That's one output file that we get from this process. Another one, as I mentioned, is the point cloud. It looks exactly the same, as it should, because that ortho image was generated from this point cloud. But if we zoom in, we'll start to see these are individual points now. This is what was generated based on that analysis process. Analyzing the overlapping images, recognizing features, recognizing structures, recognizing arrays of pixels in multiple images allows the reconstruction of this 3D environment. Now, obviously, we're looking at this in 2D right now, but if I pop up my 3D viewer, we'll just bring it up into view a little bit better here. You can see this is really cool 3D data. This would have started simply as overlapping simple images, and through the process in Pixels to Points, we generate this 3D perspective. I'm going to be coming back to this in some of my future show and tells today to show what we can actually do with this data. But for now, that's the second output. Now, the third is my favorite. This is a mesh. This is a 3D model. Once again, it looks the same. It's the same target area derived from the same data. This is actually a vector file. It's a vector file on which the actual visual representation, visual characteristics are superimposed. And again, 3D gives us the best perspective of this. This is a model. This is now a 3D model, a solid surface 3D model generated from the points again. It's a vector file generated from those points. This is a mesh or a 3D model output option from the Pixels to Points tool. So that is reason number one why you might want to consider taking a look at the LiDAR module to do what I just did. Again, the raw material, quite simply, are drone images with sufficient overlap. So number one. Number two, because you need those advanced point cloud filtering tools, let me bring up a different workspace here. I have a couple of versions of Global Mapper Loader. Let's talk about some of our filtering options. So here we have a standard LiDAR file. This is not photogrammetrically generated. This may be something you downloaded from a website or maybe collected yourself. We've got filtering options. And obviously, before you embark on any process with any point cloud data, you want to take a look at what points you need to work with. Is it a DTM you're generating? You might want to get rid of your buildings and trees. If you're doing extraction, you don't need your ground points, etc. So those filtering options are available. Now we have a filter tool right here in the toolbar, conveniently located right at the end, and allows us to filter based on the classifications. We've got them all turned on right now. Also, we can filter by return type. With those multiple returns per pulse, we can determine which ones we want to isolate. So it's two very basic filtering options here. What additional filtering options the LiDAR module brings are based on the selection of the points that you want. Now, to visualize this, I'm actually going to select the layer and use my select all tool. I'm going to begin by selecting all of my points. If I right click and go to advanced selection options, I have an option here to filter LiDAR not just by class and return type, but by any of the variables you'll see here. We can filter by, obviously, elevation. We can filter by above ground elevation, filter by classification, once again, return type, scan angle, intensity. All of these variables that are associated with our LiDAR points can now be the basis for our filtering process. And obviously, multiple variables can be applied here. Also, we can vary based on color, if colors are present. And this is a good way, again, to remove certain types of points or to isolate points, maybe that match a color characteristic, road surface or vegetation types. So this is a very, very, very powerful filtering tool, and it basically dictates which points are going to be selected. Ultimately, then you can copy and paste those selected points into a new layer or delete the ones that are not selected. There's a number of different options in there. So point filtering, not just very basic classification or return type filtering, but also, as you can see, based on any variable. I'm not going to demonstrate it, but we could also run a query. I'm not going to open the dialog box, but we could search, because these are vector points, and build a query based on those variables, again, as part of the process of filtering data. So bullet number 2, why you might want to take a look at the LiDAR module is because you have a need for some advanced point filtering tools. This is a good one as well. Because you want some interesting ways to visualize your point cloud. And obviously, if you look back to where we just were, visualizing my point cloud, you can see I've got the points represented by a color pattern. That's actually a shader that's selectable from this drop down up here. I can change that, as you can see. Just basically, it's a elevation shader that's being borrowed by our vector points to represent specifically elevation in this case. But if I use the LiDAR toolbar drop-down, you can see there are many, many other variables. I want to point to just a few here. We can view this point cloud by intensity. Now, people often think, well, this looks like a black and white photograph now, as it should, because this is a measurement of the intensity of the return of the laser pulse. And obviously, this will work just with LiDAR, not from an XYZ or a photogrammetrically generated point cloud. But you can see now we have an intensity visualization. We can obviously view by classification. I'm going to come back and look at this one a little bit later, but we're looking now at points that are identified as buildings and vegetation and ground, and the gray ones are unclassified. I could even throw up a legend to help me to describe what these colors represent. What else we look at? Return number. This gives an indication as to many returns there is per pulse. As one would expect, you see areas where there's vegetation, we're getting more returns. Again, a legend would describe that for us and what these colors represent. So another way of visualizing our point cloud. I really like this one, height above ground. Now, height above ground doesn't exist as an attribute. So when I select this, it basically does a calculation on the fly to determine where each point would belong in three-dimensional space above a known ground level. And that is what has been calculated. In fact, if I click the info tool, each of these points now has a new attribute, height above ground. So we're actually able to attribute our LiDAR data and visualize it at the same time using that tool. One other visualization thing that was mentioned by, I'm trying to remember who it was in our sales team, I think it was Miles, the profiling tool. This is only available if you have the LiDAR module, the ability to create a cross-sectional view of a point cloud. Simply draw a line. You can also define the swath width, by the way. This is an important consideration when dealing with point cloud data. We're not dealing with a solid surface, so we need to define what that swath is. I'm just going to quickly change this from 1 meter. I'm going to go up to about 10 meters here. That's the width, and you'll see that represented in this line. I'm just going to draw a line through this building here, and you'll see that 10-meter wide swath. That's what I'm seeing here. So we have this cross-sectional view now of our LiDAR data, not just a single line, but obviously, as I said, we're looking through a 10 meter wide swath of points. This dialog box, by the way, gives us a lot of other options, which don't have a chance to go into in detail, but things like editing, we can select points and edit them. We can create perpendicular profile views like this for perhaps digitizing features, for tracing features and sequential profile views. A lot of different functions are available in this visualization. So again, just a few options as far as point cloud visualization is concerned within that will be available in the LiDAR module. How are we doing here? We're up to 3. Okay, what's number 4? I'm surprising myself here. Because you need to improve the quality of the LiDAR data. This is an obvious one, and I think Jody mentioned this as one of the highlights or one of the reasons you might want to take a look at this. I have a list of bullet points here, and I'll bring up the software to actually point these out. Let me get rid of this example. We're not going to save our changes, and I'm going to bring in another workspace. Bear with me for 1 second, because we're actually going to do a quick demonstration of one of these tools. But before we do, there's a lot of tools in the toolbar here that could be defined as improving the quality of your LiDAR. I want to point to this one first of all. This little tool will identify noise points. Those points which are obviously way above or way below what your expected threshold will be. And you can define the parameters of what constitutes a noise point or noise points, either reclassify them or immediately delete them. That will improve the quality of your data as well. While we're in this little array of buttons, these are the automatic classification tools. I'll be using this one a little bit later. Identification of ground points. Obviously, having no classifications, not very useful. You're going to improve the quality of that point cloud by identifying those points which are ground, which are buildings or vegetation, which are power poles or power lines. These are tools that are available for assigning those classifications. There's an array of tools for assigning classifications manually. You select some points, you want to make them building points, you just click this button. It will automatically change the classifications. What else can we do? We can offset the vertical, the Z value or the Z value in your point cloud using our QC tool. You go out after the data is collected, you do some ground control collection. You can then essentially create a version of that point cloud in which the local points around a collected ground control point are offset and every other point is interpolated. So this tool improves the quality by improving the vertical accuracy of your point cloud. I want to point out as well the rectification tool that some of you may be familiar with. I'm just going to quickly bring this up. I'm not actually going to demonstrate it, but this rectification tool that's typically used for rectifying an image or rectifying some raster data that likely doesn't have any geographic intelligence. You can use this with LiDAR or any point cloud data as well. And what we've just introduced is the ability to transform this not only from an XY perspective, but also a Z perspective. So you can improve the quality of your LiDAR data by reassigning the geographic location based on establishment of control points using this method as well. When we get into looking at some of our terrain analysis functions in more detail, we'll take a look at that in more detail in a future session. What else? Let's go ahead and demonstrate this one. This is why I brought this example up. LiDAR Fit right here in the toolbar. This is a fairly new tool that we've added. Those of you who maybe attended our What's New in Global Mapper 21.1 webinar will have already seen this. For the rest of you, this is a very interesting example where we've got 2 point clouds and they're visualized differently just to distinguish them. If I use my profile tool again, which we quickly demonstrated a few minutes ago, but in this case, I'm going to bring the width down, back down to 1. That's perfect. So 1 meter wide swath, and I create a very short little profile just across this transitional boundary between my 2 point clouds. What you will see is, oh, it expanded, of course. For some reason it changed. Let me go back and change that setting once again. Oh, it says 1. I don't know why it expanded, but okay. We'll hit OK again. But anyway, let's see if this brings it up this time. And we will see. I think I got a tree there. I don't know why it's not cooperating, but take my word for it. You would notice an offset, basically. One is literally sitting on top of the other. So the tool I'm about to show you basically compensates for that. It allows you to take one of these point clouds, establish that as the base point cloud, and adjust the other one. Basically define what that offset distance is. First of all, we do it mathematically, and then we can make the decision, if we choose, to apply that offset and move the adjacent point cloud so it matches. It will literally match those points to each other, and everything else then beyond that is interpolated. So it's a way of matching point clouds together. This perhaps would be the case if you've got 2 flight lines that were flown at different times, or perhaps 2 point clouds that were flown different seasons or different time frames, maybe different years. If you're confident in the quality of one, you can use that as the basis and automatically match it. Okay, enough talk, let's do it. This is the tool right here, as I mentioned. You choose first the point cloud to match to, and then the one that's going to be adjusted. I'm going to leave the settings as they are just by default. We'll go into the technical details in a future session. For now, we'll click OK, and that's going to chug along. I'm going to actually leave that to go. It's going to take about a minute, maybe a little bit less. But while we're waiting, I'm going to go to my next little demo here. I know we're kind of going a little fast along here. I'm going to unload this example. I'm going to bring up another point cloud for my next bullet. So we're multitasking here. Okay. Basically, improving the quality of the data was what we summarized over the last few minutes, and this example of our best fit will show that specific example. Number 5, you want to create a 3D mesh from your point cloud. This is, again, unique to the module. This is not available without the LiDAR module. With the pixels to points tool that we demonstrated, we got a mesh. That was an automatic output option from that tool. We generated that mesh. We looked at it in 3D. But you can also generate a mesh from the points themselves, from LiDAR, from any point cloud. So let's take a look at an example. Again, we've used this in the past. This is a little farm scene. I think this is somewhere in Vermont. I'm going to select the points to use for the creation of my mesh. I'm going to use my digitizer, and specifically I'm going to use the selection option here to select by polygon. That's where my cursor is. And I'm just going to draw a rough polygon around some of these buildings, perhaps some of the trees, well, a little bit of a zigzag here, and pretty haphazard, but you'll see the results in just a second. Very haphazard, in fact. So this, all we've done here is select some points. The mesh generation functionality is initiated again. Another new button here, another button in the LiDAR module toolbar. Create 3D model from selected LiDAR. And again, I'm not going to go into the details here. We'll just use the default settings, and we'll let that chug away. Now, while we're waiting for that one, let's go back and visit the street scene, see if it's finished. It's almost done, almost finished. There's a race here between these two processes. We'll stay with this one while this completes, because it's interesting. The first output that you're going to see, or the first result of this process that you're going to see, is actually a summary of the underlying math that's applied. It's literally calculating what that best fit would be, and then it will allow us to apply that to the point cloud. I think if I talk slowly enough, it will catch up with me. So again, finding the nearest neighbor points, as you'll see here, and when it completes, hopefully my profile will cooperate so I can look at the cross-sectional view again. And we'll see that that offset. The offset in this case, if we actually did get to look at that profile, was only about 10 to 15 centimeters. It wasn't a great deal of offset, but and we were able to, in the dialog box, establish what that threshold distance would be. So here we have summary that about just under 40 centimeters of offset between the two. This is on the X, Y, and Z axis, by the way. It's not just a vertical offset. And we're going to transform our point clouds. It's basically shifting all the point clouds from the target point cloud, noting the math. Again, we're not going to go into the technical details right now. Click OK. You notice a little shift on this point cloud to the right, and I'm hoping my profile tool will work this time. We'll find out. And again, it's expanded for some reason. It looks like my setting isn't applied, but take my word for it. As part of this process, it was able to shift that right-hand point cloud so it matches perfectly. It seamlessly integrates. Obviously it'll work better when you're using it yourself. So again, best fit between 2 point clouds. Let's go back and check to see if our mesh got completed while we were talking there. Okay, we have a new layer, a surface mesh. I'm going to turn off the points themselves. And you'll see this is a little bit of a coarse mesh because it's not ideal data for this, but top down it looks like almost like a raster layer. Popping up my 3D view to give it its best perspective. You can see now we have a pretty crude 3D model. It's not the best data for this, but you can see we've got a little model of a house, a model of a barn right here. And we have essentially, using our LiDAR points, generated a vector version using the colors embedded in there as well. Okay, I think we're making progress. We're about halfway through my top 10 list here. So again, summarizing, if you've got a drone, absolutely. If you need those filtering tools, Global Mapper, the LiDAR module's got lots of ways to filter your data. Visualization of your data. One thing I didn't show you, I have on my notes here, I'm just glancing down, the ability to color LiDAR. You have an option in the LiDAR module to actually apply color from an underlying raster, maybe an aerial image, to a point cloud. If I have a chance at the end, I might take a look at that one. Improving the quality, very generically, improving your classification, improving the accuracy, positioning, both in the on the X, Y, and Z axes. One of the examples we showed you just then with that best fit. And because you want to create a mesh. Okay, where do we go from here? This is an important one because you need to identify and isolate ground points, and you need to create a DTM. Let's go back to where we started. We'll say goodbye to my little farm mesh here. Let me unload, and we're not going to save. And let's go back and bring up, hopefully it's my recent menu. Let's go back to our workspace called drone. And we're going to isolate the point cloud. And we are going to look at this point cloud based on its classification, of which there are none, as you can see. So to be of any value, I need to distinguish individual point types within this point cloud. If I'm doing an extraction exercise, if I'm identifying buildings or vegetation, I need to identify which points are buildings, obviously, or vegetation. If I'm creating a DTM for terrain analysis, maybe generating some contours or calculating volume, I need to isolate ground points. And I mentioned this by way of introduction, but this button right here allows me to auto-classify ground points. Again, not spending too much time looking at the individual settings. You can define the offset, things like that, how much flexibility you'll permit between what is recognized as ground and maybe those points that are slightly offset. I'm just going to go with these defaults, click OK, and you should see in just a short period of time here, you should see an additional color assigned to my points, that color being brown, identifying those ground points. From this, we could obviously generate a DTM. We could generate contours, as I mentioned. We can do perform any of the analysis functions that require you to have an elevation surface. And there we go. So we've identified ground points. Those gray points are still unclassified. We could filter those out. The remaining points are ground. And we can quickly take a look at our profile again. This is going to be a slightly different profile view because it's not through LiDAR. Actually, it is. I'm sorry. It is through LiDAR. I haven't created my model yet. I was thinking I've created a DEM, but I haven't. Let me verify that this is actually the setting is applied as before. We'll go to our settings. 10 meters now. Let's go down to 5 meters in this case. I think it's because I have multiple instances of the software running. That's why it's getting a little confused with these settings. So a 5 meter swath through a section here, and you'll see it's nicely identified ground points. You can see a few little gray patches here. These are probably above ground anomalies, but at the very least we've been able to isolate our ground points. So maybe try another area here, and again, yeah, you're looking quite clearly at our ground points identified. A little mound of something here that's considered something other than ground is still unclassified, and that flexibility in my setting was about 30 centimeters above and below. I might want to tighten that up just a little bit to get a more precise ground surface. So again, one of the major reasons why you'll want to be taking a look at the LiDAR module is if you have any point cloud data, whether it's drone derived, whether it's some LiDAR that you've acquired, you're not confident in the quality of those ground points, you can run through that process and identify ground points for creating a DTM, a digital terrain model. Number 7, this is a good one. You need to query points by proximity for encroachment monitoring. Once again, I'm going to grab one of my copies of Global Mapper and I'm going to load up another workspace, and this one takes a few seconds here to load. This is a power line. The encroachment, we don't call it encroachment, it's a proximity search tool, allows us to identify points within a point cloud that are within a defined distance of either another type of points, another classification of points, or a line feature. Now, obviously, this is ideally suited for utility encroachment applications, and that's exactly what we have here. We have a power line, and when our point cloud actually draws in, you can see we have classified points, including, it's difficult to see, so I'm going to apply a filter very quickly here, but we also have wire points in here. You'll see them now. I want to conduct a search to determine where the vegetation points that are close enough to be to these wires to be of a concern. So let me turn these all on again, and the tool that we're about to initiate, we're slowly picking these off one by one, is the Select LiDAR by Distance tool. I'm just going to do this for a small section just in the interest of time. First of all, define my distance. I had searched based on 15 meters. We'll keep that value. So in other words, 15 meters from my wire conductor, which is my class 14, my power lines, I want to look for high vegetation. Those are the vegetation points. Again, we could also use a line feature as the basis of this search, but we're going to search for points within a certain distance of points of another class. Again, let me just define this based on a slightly smaller area. By the way, the map is inverted because I adjusted the orientation of the original map. That's why we're seeing a different perspective here. We're just doing this in a small area. Click OK again. And hopefully I chose an area where there actually are some, not very many, just 900 points. I think further out here, there's a few more, but you'll get the idea. These little highlighted points represent those points that are high vegetation, that are within 15 meters of a power line. If you're sending a crew out to do some, maybe with their chainsaws to do some clearing, you'll know where to identify or where to send those folks. So that encroachment, that proximity search gives you a lot of very good results as far as this workflow is concerned. Okay, and where are we going next? Number 7, number 8. This is a good one as well. Detecting change. Change detection is something that we've had in Global Mapper for quite a while, based on a surface model, a raster surface model. We have a tool for subtracting one surface from the other that allows you essentially to determine what change has occurred. So we've had that workflow in our arsenal for a while. What we've introduced fairly recently is the ability to do that within a point cloud. And I'm going to show you that one as well very quickly here. Let's bring in another workspace. This one you may have seen before as well. We play with this data a lot. This is obviously a pebble field, you can see from what we're looking at here. Very local, small area point cloud. It is a point cloud. It looks like a surface, but it's a point cloud. And there are 2 passes here. Basically the data was collected twice. And between those 2 passes, there was some changes made. Specifically, some rocks were removed. And this is obviously set up for this exercise specifically as a change detection exercise. How do we determine what changes occurred? How do we isolate what changes occurred? Well, again, the new tool in Global Mapper, this one right here, I'm trying to move my cursor, compare point clouds. This allows us to choose which point cloud to compare from and which to compare to, basically. Again, settings which we'll go into in detail in a future session. How much offset do we allow before we identify change has occurred, things like that. And we'll just go ahead and run it based on these defaults. And it should identify and actually create a new layer that specifically identifies which points have changed between pass 1 and pass 2. In other words, when dataset 1 was collected in dataset 2. Obviously in the real world, not in this simulated world, applications for this might be agriculture or forestry or engineering or maybe highway monitoring, landslide monitoring, things like that. Here we have obviously a very simulated example, and we can see quite clearly where the change occurred. I can turn off the original 2 point clouds, and these are basically just selected points now. I've isolated them, and you can see quite clearly where change has occurred. So very simple. Change detection, a little bit of anomaly over here, something else obviously changed. But that tool is now available natively in the point cloud. We don't have to transform this into a raster surface and then do a subtraction. This can be done right within the point cloud. I have a couple more. Number 9, hydro flattening. This is something that's not necessarily related to actually managing the point cloud itself, but what you can do with the point cloud in terms of transforming it into a surface. I have a very simple example of this workflow. Hydro flattening, by the way, while I'm trying to multitask, load the data and talk at the same time, hydro flattening is a process whereby the elevation value in a vector feature overrides the elevation embedded in the target data for your terrain generation, in other words, your LiDAR data. So you'll see in this example, we actually have a couple here. I'm only going to do one because we are going to run out of time here very quickly. But this example, if I turn off the point cloud, you'll see quite clearly there's a body of water here. What we want to do is hydro flatten this. If we didn't, the surface of the water, we have enough points here covering the water area that it would create a very serrated surface. It would not be smooth. So what I have to work with here is a polygon. It's a simple vector polygon, and there's one very important attribute associated with the polygon, the elevation. We know what the elevation is for that surface, about 25.9 meters. And we are going to create a grid based on the polygon and based on the point cloud. So it gives me an opportunity to introduce our gridding tool very quickly. Obviously, we're not taking a great deal of time to go into the details, but this is the tool that allows us to create a surface, not just from the LiDAR, but also from the pond layer, being able to select those layers here. The important part here, the difference that you'll see because we have that vector feature is the ability to use that 3D area or line feature as a break line or soft edge. In other words, we're going to flatten the terrain based on the Z values in the polygon, ignoring the point values essentially. Let me filter the points just so we're looking at ground. Just number 2. And again, in the interest of time, I will define the extent based on a local area here. So just around the pond itself. And this should not take long. And when it completes, we have a new grid file. We'll turn off a few layers here so we can see the results. And there we have a hydro flattened pond feature overriding, as I mentioned, the original points. It is also feathered. I didn't point that out in the dialog box, but there's a feathering process around the edge, so it nicely transitions into the surrounding ground surface. You can also do this based on a line. I do have that data here, but I'm not going to take the time to show you. But if we use this line feature, which represents a stream, the per vertex elevations along this line would be burned into the terrain, essentially creating a nice little valley so that you can guarantee that the stream actually flows downhill. So hydro flattening is another reason to consider the LiDAR module. Number 10, you need feature extraction. This was actually one of the highlights for a long time, the ability to generate vector features from your point cloud, your classified point cloud. I think that's been overtaken, as we saw in our discussion, or we heard in our discussion with the sales folks. Pixels to points is really the highlight now, but this one is still very, very important. And for my last demo here, let me unload our ground point layer, and I'm going to go back and look at one of the layers we looked at earlier. One of the workspaces, I'm sorry. We're going to go back to this first layer. And I'm going to do an extraction exercise to generate 2 types of vector features from this point cloud. We're going to generate a building, basically 3-dimensional buildings, vectorizing the building points, and also trees. We have vegetation here. So we're going to actually identify individual tree points. Again, with apologies, I'm not going to spend the time to go into the details. I'm simply going to use the default settings that we have in here for extracting 3D building footprints and extracting 3D tree points. We'll click OK, and we should see a couple of new layers in the control center, and we should also see the features obviously displayed on the map itself. And we're going to actually take a look at these in 3D when they come up in just 1 second. And actually, to make this a little cleaner, I did notice when I tried this earlier, some of the trees you see are actually based on the returns around the edge of the building. To make this just a little cleaner, and just because I'm a perfectionist, I'm going to delete these because we know these aren't actually trees, but that's okay. We'll just go ahead and select them first and hit the delete key on my keyboard just to get rid of those. Okay, let's turn on the building outlines again. We've got our trees. I also have a terrain layer that's underneath. We're not seeing it. That'll give us a kind of a geographic base. I'm going to pop this up in 3D so you'll see exactly what we were able to generate through that extraction process. A little bit of a drop off here because we only have a small area of underlying terrain, but we have a 3D model, a 3D vector model of that school building as well as the additional buildings. We also have individual models where it's recognized trees. These trees, the scale of this model reflects the height that was recognized in each tree, and obviously gives you a nice geographic perspective when you look at this in 3D. So that's an example of being able to extract vector features from a point cloud that are appropriately classified. It's looking obviously for building points, it's looking for tree points. We can also extract power lines, power poles as well. Those are additional options. And breathe. I challenged myself to get through my top 10 list before the top of the hour, and I just got there, just and no more. So that is basically the highlights of the LiDAR module. With thanks to the folks in the sales team for giving their perspective, for helping me to come up with this list basically of what the highlights were. Hopefully this whistle-stop tour has whetted your appetite. Maybe you want to take a look. I don't know if anybody's still in the silence here from the sales team. Chris, are you still there? Anything you need to add at this stage?
That was a great demo. Thanks for that.
Excellent.
Yeah, no, I wanted to wrap things up. I wanted to thank everybody here for being able to, attend a GeoTalks Express, that's focused on the LiDAR module. It's great to be able to address an audience that we know are interested in the evolution of the tool. And, one of our goals to increase the overall awareness of the new features we've released over the last 12 or 18 months. This is the perfect venue for that. So I did want to say one last thing, though. Since the world has pretty much changed over the last month and so many of us are still working from home, we want to engage customers. That's something that we've decided here at Blue Marble to do. And we all thought that offering an online demo of either Global Mapper, LiDAR module, Geographic Calculator would be well received. And we've received, some immediate reaction, but I wanted to let you know we can give you general or targeted overviews, and you can schedule these at any time convenient for you. Now, you can do this in two ways. You can visit bluemarblegeo.com/trial and set up a good time for a demonstration that way. You can also download free software trial as well to evaluate the latest version. So we hope your organization can take advantage of these demos. It's basically designed to reach yourself, other members of your team, in a format similar to this. So definitely let us know so we can schedule those. And I want to thank everyone that attended. I want to also thank the Blue Marble sales team, and of course, thanks to you too, David.
Yeah, sure. Thanks, guys. It's great to have a lot of different voices on our webinars. I know a lot of people are sick and tired of listening to my voice. We overshot just a little bit, with apologies. A couple of housekeeping things. Our next session is 2 weeks from today. It'll be in the morning here, East Coast US. We kind of alternate morning, afternoon session. It's a good one. I recommend you take a look at this one. This is the kind of the hidden features, those hidden gems in Global Mapper that maybe you're not aware of. I love doing that session. There's a long list that I love to expose. Some maybe lesser well-known tools, if that's an appropriate term to use. You will receive an email, as I said, with the recording. I apologize, I haven't been able to answer the questions. As you can see, there's a lot to cover today. We have the questions here. We will send you individual responses to your questions. We will also post the questions on our blog, and you'll get a link to that. So look for an email in the next few days with a link to this video, as well as the answers to the questions. Thank you, sales team. Thank you, everyone, for joining us today, and we will speak to you in a couple of weeks.
Thank you very much, sir, for helping today with your expertise. That was really powerful LiDAR tools, and I'm sure this is what people are waiting for. So thank you so much for joining with us, and we'll see you soon. Alright, the next session will be using Bahasa to give you a better understanding in terms of Global Mapper features and its license. Baik, untuk selanjutnya, partner saya akan mendemonstrasikan kepada Anda bagaimana cara membuat DTM dari data LiDAR dan juga bagaimana data tersebut divisualisasikan secara 3 dimensi. Kalau begitu, saya persilahkan kepada Mbak Anggun.
Terima kasih, Lukman. Pertama-tama kita buka dulu Global Mapper. Kemudian kita open data, kita buka data point cloud yang sudah kita siapkan sebelumnya. Point cloud yang saya gunakan di sini bagian pegunungan, jadi biar nanti terlihat pada saat kita meng-create digital elevation modelnya. Untuk tampilan point cloud tadi adalah sebagai berikut. Nah, warna ini menunjukkan elevationnya. Kita bisa ubah juga simbologinya by elevation, intensity, classification. Tapi kita akan pilih RGB aja yang biasa digunakan. Selanjutnya kita akan membuat data DEM-nya dengan mengklik Create Elevation Grid. Pada deskripsi jangan lupa kita beri nama DEM atau Digital Elevation Model atau sesuai dengan yang digunakan. Kalau misal kita zoom, data DEM tadi adalah sebagai berikut. Kita bisa lihat visual 3D-nya dengan mengklik 3D modeling. Tampilannya adalah sebagai berikut. Jadi terlihat jelas elevasinya di daerah pegunungan tadi. Nah, selain itu kita bisa mengubah simbologi pada data DEM ini. Ada Atlas Shader, Color Ramp Shader, ada Global Shader. kita pilih atlas shader aja yang biasa kita gunakan. Kemudian kita akan meng-create kontur. Jangan lupa pada deskripsinya kita ubah dengan garis kontur. Kemudian kita pilih interval konturnya. Di sini saya pilih interval kontur dengan 5 meter. Pilih OK. Tampilan konturnya sudah jadi seperti berikut. Nah, di sini kita bisa lihat interval kontur mayor dan kontur minornya. Ini kita bisa setting. Kalau kita lihat 3D-nya, data kontur tadi adalah seperti berikut ini. Karena kurang menarik, saya akan mengaktifkan data DEM sebagai database map. Nah, berikut tampilan data kontur di atas base map digital elevation model. Jadi ini adalah bentuk 3D-nya. Di Global Mapper kita bisa melihat visual 3D data DEM. Ya, dan data kontur pastinya. Terima kasih semuanya.
Baik, di sini saya akan menjelaskan mengenai lisensi dari Global Mapper. Lisensi Global Mapper terbagi atas 4 jenis. Yang pertama adalah Not Lock License. Jenis license ini khusus untuk satu komputer saja atau single use dan tidak bisa dipindah-pindahkan license-nya. Nah, yang kedua adalah Floating License. Jenis license ini juga sifatnya single use, namun bisa dipindah-pindahkan ke komputer yang berbeda-beda. Anda cukup menonaktifkan license tersebut dan diaktifkan kembali ke komputer yang ingin Anda gunakan. Nah, yang ketiga adalah Network License. Untuk jenis license ini, minimal pembeliannya adalah 2 buah atau 2 license. Dan license ini bisa digunakan bersama-sama di komputer yang berbeda. Dan yang terakhir adalah USB Dongle License. Jenis license ini sifatnya single use, namun bisa dipindah-pindahkan ke komputer yang berbeda-beda. Jika ingin pindah, cukup dengan mencolokkan USB-nya di komputer yang ingin Anda gunakan. Perlu diketahui bahwa lisensi Global Mapper ini sifatnya perpetual, artinya permanen atau selamanya. Jadi pembelian lisensi Global Mapper ini sudah termasuk maintenance dan support, di mana hal ini sangat bermanfaat agar Global Mapper yang Anda beli selalu terupgrade ke versi terbaru. Lalu bagaimana cara mengaktifkan LiDAR modul? Nah, untuk mengaktifkan LiDAR modul, Anda harus membeli lisensi dari Global Mapper, sebab LiDAR modul ini merupakan ekstensi dari Global Mapper.
Hopefully, get some of the highlights that are appealing to you. And if you're interested in buying Global Mapper and LiDAR module, or if you have any question specifically on licensing, feel free to email us at here. We'll be happy to respond to questions that you ask as soon as possible. Also, you can also visit our website for more information at www.geonet.co.id. And if you want to try out the latest version of Global Mapper and LiDAR module as well, you can download for trial at bluemarblegeo.com. There's some new features and tools that's been added there. Don't forget to check out our social media right over here. Make sure you follow them up so you can keep an update from us. So yeah, that's all we have for today. Thank you so much for joining with us. We'll see you in the next time and have a good day. Bye.